Thank you. Yeah, so the idea is to tell you a bit more about what we're doing and the challenges we've been facing with a growing startup, about all things data, how we had challenges in terms of getting more insight and how we solve those to continue to grow and support our product development. But just before we do that, I think it's good for us to give you an introduction about what we're doing in terms of the ecosystem we live in. So I'll be the boring guy talking product for 5 minutes, and then we'll dive into the tech and the core of it, because I think it's important that we get the context about what we do. It's a bit special, so that all the challenges that Artiom is going to present you and how we solve them makes more sense in contrast to the context. So as we propose, we kick it off like this. We can get the slides up and running. So we are very techy guys, as you can see. There you go, it's pink and it's good. So we're AdsWizz, maybe some of you have heard about us. So we started focusing on helping the audio ecosystem grow. And we see the audio ecosystem is that really we're all about audio. I don't know if it speaks to you. We do audio ad tech. And basically audio ad tech is look at it. You have video, you have display on the web, right? You see a banner, you see a video ad. Well, we do the same but for audio publishers. And not only do we do audio, but we're a bit nerdy about audio. We believe that audio is very different, and audio is very unique in what we can give to users and what we can present them in terms of content and advertising. So we are doing things way differently than video and display. And just to illustrate what we believe is the impact of audio, I'm gonna ask you guys to jump in here. So, close your eyes. This is serious. Close your eyes and just pay attention to what's gonna go. And we'll figure out later how you see it. So this is where we have some audio. Let's try it again. Close your eyes.
Magical. To take your eyes on a journey across hundreds of miles of African landscape is to rest your eyes to a peace never known before. And to bring you so close that you're eye to eye with a Rothschild giraffe. And then to reset your soul as you align to the rhythmic chanting of Maasai warriors. You have to go to Africa, yes, but you've got to go to Kenya.
So no picture, right? You close your eyes, you imagine something. And I'm sure you imagine landscape. You made your own picture, because in absence of image, your brain worked for you. Your brain visualized it. And now, if you compare with this advertising, which is most appealing to you? The image you picture getting exposed to audio, or this display? I think in many cases, you imagine much more. Much greater landscapes, much more adventure. This is where we believe audio is different and is impactful. Not only is it impactful, but it's also very intimate. It's the first sense we develop when we grow up. This is not a portrait of me, but it illustrates that it's with us. It's something that we engage with. It's very personal. And just look at your daily life. When you go to work, when you're at work, the things you do while you're working, while you're commuting, is usually limited, but there's one thing you can do while doing something else, is listening to audio. When you're on your phone, browsing social networks, checking emails, you can listen to audio at the same time. And that creates a deep link with the user, and that enables you to speak to an audience, to engage this audience. It's going to be reinforcing the message. It's going to be able to trigger much more actions and much more way of converting, getting the user to a store, getting the user to click on a banner, just because we're speaking to someone. And all that format behind the scenes, relevant is only if you have the good tech. So what we do, we are not selling ads, we're not creating ads, but we are the pipeline between the advertisers who wants to reach an audience listening to a music service or a podcast. So we are really the plumbing. We help agencies get campaigns online and find the right audience at the right moment, and that every single second, and that transaction cannot take more than a couple of milliseconds and carries a lot of information. So you see where I'm getting when it comes to data. A few of the brands we're working with to give you the scale. It's all from the guys like Spotify, like Deezer, that are using our tech to get ads out to the users. But also more traditional broadcasters like FM stations, which are present online and want to replace the usual ads you will hear on the FM by one-to-one targeted ads online. And just before I hand it over to Artiom, just a few numbers to give you the idea about the impact. Today, we have more than 10,000 publishers connected on our platform. And when I say publishers, Spotify for us is one publisher. So imagine the scale at the end. That's millions of users connecting at any given time on our system. And to give you an idea, in the US only, we're talking about billions of hours of listening every single month. So we have, on one hand, this huge pile of audience, and we have a growing number of campaigns, number of messages that get to deliver. So a lot of advertisers running a lot of campaigns to a lot of audience having very specific needs in terms of targeting. So why are we aiming high? Why are we challenging now in terms of data? Just because we need to better understand the users. There is more and more data coming in. There's more and more listening signals. How do you listen? What device? Where are you? And that's in real time for us to better improve and better deliver. That's why we're facing a challenge in terms of data, and we're going to walk you through how we faced the challenge and how we went forward with a new data stack. Artiom?
Thanks, Erik. So, before actually diving into the technical details, I'm going to ask you a simple question. How many of you guys have ever been exposed to an ad? Pretty much all of you, right? But the real question is, how many of you have ever been exposed to an ad that matched perfectly your needs? Because that is actually something that you would like to look at, right? So how do we actually know all of that? Well, it's actually pretty simple. It's all about the data around you. And I'm gonna show you just a simple example. So you are a listener, you connect to radio, so you just come with some of your data. Then radio actually is doing a request to one of our servers, augmented with even some more data. And then our engine is doing some of the processing, augmenting even with some more data, and then actually doing an ad selection based on the data that we collected, and that is served back to the radio, so that then you are exposed to that ad. So how do we actually do all of that? If you will notice, you do have plenty of activities. So we do store all of those events per activities, and an activity is nothing else than a bunch of the same type of events and all the data that matters to them. Just to give you a simple example again, is that let's say the radio is doing then a request to our engine, so that means all the events, add request, we do collect all of them together for activities. While looking into that data, actually, what we want to analyze on that is that you do want things like you want to do group bytes, which we call dimensions, and most of the time you do want to do sums, counts, count uniques, do means or average or avoidance and things like that. Those are the metrics. And what is important to you is actually also to understand a certain period of time, right? You want monthly, daily, or whatever. So what you actually do, you do store also the particular timestamp of that event that actually happened, right? And just to give you just a simple example, we do have more than 100 of dimensions that we collect, and also more than 100 metrics. And that actually can scale because some of our clients can send dynamically the number of dimensions that we want to analyze for them. Okay. So how all of this analysis has been done before? Okay, that's the main question. We had a typical batch processing and a real-time processing. And to notice here is that, okay, we had a lot of producers that basically been pushing the data through Stripe into, let's say, S3 buckets. Okay, and those being some small files, small chunk of files. What we've been doing next is basically we had some batch processing that were aggregating the small chunks of data in bigger ones, so that you benefit from the performance of having a batch processing. And then doing filtering, joining, and actually augmenting with some even more data that was not get by the producers. Okay, and then that's actually the pre-processing step. And the next one is the processing itself, where you actually can predefine all the potential permutation of your user, so that you create breakdowns per dimensions. So you know what you need, you do create those, compute them, and store them in a key-value storage, which is database. Okay. On the other side, the real time, it's pretty straightforward. We do collect the same, we do take the same small chunks of data, and basically we have some Java applications that just take the files, process them, and compute some of our business required metrics and damages. We do store that in MySQL. And in the end, you have an API that basically consumes the data, whatever it's historical or real time. And with this architecture, actually, here comes the limitation and challenges, right? You do have to maintain two code bases. One is the real time, and one is the batch. So whatever you want to come with the feature in production, it takes a while. You have to see whatever you don't break on one side or another one. It's also challenging because you don't have only one API that basically have to take the data from historical and from the real time, and you will want to do those aggregation things. Let's say you take a breakdown from here and a breakdown from here, and you want to aggregate them at once, right? Here come the challenges. If you take a, let's say, bigger interval of time, you will certainly have some of the resource constraint, or the latency will increase. So whatever you decide, let's say if you want to reprocess some of your data, right? Well, if it's coming with the batch processing, it takes a while. And if the interval increase again, it takes a while. So your manager gets pissed off. You want, okay, I'm going to solve that. Meanwhile, actually, what you notice is that we are using actually Amazon. So what we notice is that, okay, some of our instances from Amazon don't react as those supposed to be. So we have some of the batch processing jobs that running continuously. So, okay, I have to kill the job. Then your manager comes and says, okay, I'll kill you. And you say, okay, you probably will kill me, but not. So what you're doing is that you scale more and more so that you finally process what you have to process. So by scaling that, even Hadoop, it's not so good at that. It's not like it's cutting your time at half. It's just reducing a small amount of time. But you already spend time because you have other issues. So scaling and scaling, it's obvious that you just increase your infrastructure costs. And your manager gets pissed off again. You just wanted to process something and your costs are increasing and increasing, okay? While speaking about the real-time part, is that you usually want to focus on something really lightning fast, so that you compute small data that you really need, some kind of couple of dimensions, couple of metrics. You store them as soon as possible so that the user can query the data. So you are reduced on the number of dimensions and metrics, actually, not as you would have it on the batch. And while pre-computing all of the data that actually your user can use, it's not so interactive, right? Because you do pre-compute everything, and that's most of what you can do with the data, right? So, and this is actually also annoying for the other user, because most of them probably don't use all of your breakdowns, all of your dimensions that you computed. Let's say they do one only, let's say a country and a city, but some of the other ones only countries, so they don't really care about the other breakdowns. So that data, it's actually unused, so you don't need that. And by hitting all of your clients with the same breakdowns, you actually also do the data explosion, right? Because you want to keep all the things. Whatever, if you decide to use it, you will use it, probably. So what did you want to rethink, actually? We wanted to scale efficiently, okay? Whatever new throughput will come to us and the client will come, we wanted really to scale efficiently. We wanted faster processing time. If an added count will now come in our system, we want as soon as possible to be able to query that data, okay? Having in mind that we wanted to handle millions of events per second. That's because we had the knowledge of upcoming new features and also the throughput of our clients. The query time response is really important. We do not have a huge throughput per day, but what is really important is most of our clients, they do want to play with the data and to have a response as soon as possible. So here comes the data interactivity, right? You do not pre-compute everything and that's it. You give the possibility to all of your clients, okay, I want those dimensions to combine with this one, so they really can play and slice and dice the way they use the data. And faster feature delivery. It was obvious for us that we do not want to maintain two systems again. We want only one thing to deliver as soon as possible, okay? And of course, having in mind that you will have features coming in, right? And you also want to build something in parallel. So you have to keep in mind that all of those features have to be migrated, and of course also the new clients that you want. So here comes the cool part actually. We had the chance actually to start a project from scratch, and we called it Meru, and there is a reason for that actually. By the way, who knows about the movie Meru? That's cool. So the idea is that it's about 3 professional climbers that climbed one of the hardest mountains in the world. And that's actually how a big data project actually begins. You do start with something really smooth, and then it goes like 90 degrees and climb like really, really small steps. So there is a reason for that, right? you do start to analyze one framework or another one, and then you actually understand that, okay, you have some time interval where you want to deliver something as soon as possible in production, right? So it starts to be like quite annoying, this thing. So our main principles, being in mind, we wanted something continuous processing, so that whatever framework or tool we will choose to be able to have everything streaming approach. Okay. We wanted fault tolerance. Whatever something will crash in your system, it's supposed to go back in the business. It should be scalable. As I said, we knew that it would come new features, new clients, and things like that, so that the volume of the data will really increase a lot. So we wanted to have a better scalability. Handle billions of events per day. That is really important to keep in mind for us. Query data fast and interactive. So as I said, we didn't want anymore to pre-compute everything, but to really give the possibility to our clients to start to play with the data. Okay? So we had different experiences. We've been working with a lot of frameworks, whatever it is, Spark, Hadoop, a lot of them. And we settled down actually on three main solutions that basically handle everything streaming. It's Apache Kafka, where we do use Apache Kafka, Apache Flink, and Darie. On Apache Kafka, we basically rely on everything related to messaging. Apache Flink is the processing itself, and the Darie is a column-oriented data store for all the things around all our queries. Okay. So while you're starting with project, most of the guy comes with different ideas, and I want to do this, I want to do that, but in the end, what you have to keep in mind is that you want to go with a simple proof of concept, what we call happy path. So you do start with a simple example. This is actually the Kappa architecture, right? You do have one line where everything is streamed. So the data goes how? You have a lot of producers. The data is pushed into Kafka. The Kafka is, then you do have a stream processor that basically take what we call raw logs. And then you do another modeling for your data source. You store it back to Kafka. And then the Druid has a possibility to consume the messages in streaming approach from Kafka. Okay? So here come the challenges, right? You do code with a happy path, but okay, one of the biggest challenges for us was the domain modeling itself. We challenge a lot our producers to don't give us some of the details. Okay, guys, we'll figure out how to deal with them later. But we really challenge a lot. Okay, please give us as much as possible so that we can use that, and then we'll figure out how to increase the performance on how you will query the data. So, like, let's say you have a simple streaming approach, and your producer gives you only one ID, but for that ID, you want to augment even more IDs. So we challenge that on the producer side. Okay, give us the most that you can, so that we will use without augmenting you in the process. With that said, we also come with some of the main things for our modeling. It's about IDs. If an event comes to our system, we wanted to have an ID that basically will tell us, okay, was that ID ever found in other events or not? So kind of specifying the unique per IDs, per events. The versioning itself, if we want to move to a new release, let's say, and it's totally different, to start to handle it because of a new version, somehow on the Kafka topics. And then it's about the collections. This is pretty awesome, actually. The Druid allows you to have a collection type to be stored so that you can specify a group of the same type of dimensions in a list, throw it in Kafka, then Druid ingest the data, and it's possible to actually expand the data, explode it, and you can do group bias by each dimension from that list in particular. That's pretty awesome. And then to specify common and simple way of specifying what are the uniques that I would like to compute from my model. So having that in mind, how we started is like you have different type of activities, right? And all of those activities, you do store them per topic in particular, okay? And in the end, what you want, you process it. Let's say you have a Flink job in a streaming that processes only one topic at once, and then what you want to store in the end, it's another topic, so that Druid can communicate only with that topic. So all of your activities comes in the end in one topic per client, so that wherever you start to query your data, you do not go in different topics and with multiple queries. You go only in one place and query all the potential dimensions from all the activities. Okay. With that said, here come the challenges for the throughput, because by storing the data per activity, it's obvious that all of your clients will go in the same activities, which in Kafka it's topics. Okay, so all of your clients pushing the data per activity, I do have those requests from the users coming in. I'm storing them in a Kafka. Here come the partitioning challenges, because what do you want in the end? You don't want one client to impact another one. So you want to increase the throughput and to spread that messages in somehow that you handle them faster. Okay, we've been using, by the way, the hash partitioning since the beginning. And that is actually related also while you store everything per client already, per a data source after the process log, you do want also all of the activities that have been injected in that to be also spread somehow that the Druid can ingest it really efficiently. So that is also hash partitioning in our case. By playing with all of this partitioning, we found out that most of the time we actually been crashing whatever it is Kafka we're playing with partitioning, or we did realize that there are some of the constraints in the Druid related to some of the configurations. The Flink itself also, we do have a dynamic, we do define dynamically the client from the events and where we want to store them in the Kafka topics. That's why we had a lot of issues around that. So we said, okay, let's define a happy path, a play path, where we basically can, if something will break, we can start it from the beginning. And the reason of, so we actually added kinesis as a first streaming where all of your producers will start to push your data. And then we created a bridge component that basically using Kafka Connect, it also comes from the Kafka streaming platform. It basically do a clone of the streams from Kinesis and create the same type of events in the topics in Kafka. Okay, so with this approach, we basically started to play around with our system because we knew that the Kinesis is the safe part of the project. So wherever we wanted to migrate something new or to change the instances or to play with topics, we knew that we can start from the beginning. So here comes the oops part. You will notice actually by doing such architectures that you'll have a lot of configuration issues, and then some of your instances goes down, and then you introduce a bug and you want to reprocess the data. You do have a lot of resource constraints that you didn't figure out at the beginning. You knew only theoretical part, so that you have to play with that. And then while something is crashing your system, basically you get things like data inconsistency. And here the reason is that Druid itself, the data source, allows you to have exactly once while you are streaming your data in the database, while Flink and Kafka, you might have at least once data consistency. And that's because of, let's say some of your brokers goes down and he didn't succeed to save the last state of the messages that he succeeded to consume. So then he bootstrap again, he take the last offset he knew, so that you goes with the same events processed again. And of course, a lot of performance issues. We actually started with something thinking that we wanted to process millions of events per second as a test, but we actually started with something like tens of thousands. So we wanted to improve that as well. So here comes the replay path. The replay path itself, so as I said, you have a job that basically process a stream from a topic from Kafka and store it what we call cooked data, right? So it's obvious that you might have some of the issues like data inconsistency. So what we said, okay, we will store chunks, snapshots of the topics of the messages that have been processed, store them on S3, and again, it's using a Kafka Connect application. And basically, then you do have a batch ingestion job that takes the snapshot of the data and ingests it in Druid. The reason of having a batch ingestion in Druid is that it drops the interval of the data that you want to re-ingest, and it reinserts the new one. While on the streaming approach, it augments all the time whatever events happens for the same intervals. Okay? And let's say you also introduced a bug in the processor, all of us doing mistakes, and you want to replay that data. So you do have snapshots of your raw data, store on S3, and then here comes the batch part. Basically, you take the typical batch approach. You do take logs from S3, process them in the batch manner for a certain interval, store them as, let's say, cooked, and then you use the same approach, batch ingestion into Druid. More than that, you can use actually the batch ingestion. Let's say you have a TTL of all of your clients, and you store only 6 months of data, because it's cost efficient for you. And you want to ranges for some of the clients, let's say from 1 year in the past. So you'll use also the batch ingestion. You will take the data that's been there in S3, like a snapshot, ranges it back for some of your clients. That is also cool. So the lesson learned, this is really important. We figure out that, okay, the whole Kappa architecture is pretty awesome, and you can process a lot of the data and everything is perfectly fine, but you will have data inconsistency because most of your things will fail. And the idea is that you will need the batch ingestion for your data consistency, definitely. You will need to, we found it really cool that creating the raw and cook the snapshots of your data before the processing and after the processing, you can play around. Wherever you break something, you just replay the mechanism. Or if you need something, as I said, for your clients, you ranges the data, okay? So as I already recommended, use the batch approach for your ingestion in case of replays, because it basically drops the intervals of the segments that been there already and push the new data, push the one that is not duplicated, and it's really cool. And we recommend you if you, let's say, in a transition period, you have to move client by client, and you don't know yet all of the throughput. We did have in mind the techniques of computing the partitioning. However, we knew that it's a new model coming in. So you would go with something safe, right? You don't want to break things while you are already in production. So we put kinesis over there, and we found that this is pretty useful. Whatever something goes down in your system, or you just crash something, you just rewind and you go from the kinesis back. And one of the things that is really important also is that you have to keep in mind the high availability of your data. While speaking about that, you basically, how this is happening. You replicate your data on different instances, right? And you do have to keep in mind that whatever one instance goes down, that will be that all the remaining instances will have to reallocate the data that's been lost on the remaining instances, right? So you have to keep in mind this, because if you, let's say you have 1 gigabyte of data spread across 3 instances, one instance goes down, then the remaining data that's been there, let's say 300 megabytes or things like that, you have to be reassigning on those 2 instances. And if you do not have that space, actually, you'll get some weird things like your data source would not be eligible for querying. So here come also the monitoring part. It's obvious that you want to understand wherever something comes into your system, what's going out. How we've been using that, we've been using Kibana, Elasticsearch, Logstash, and Grafana. The reason for having, so you can do actually dashboards in Grafana and Kibana as well, but the reason we've been choosing Grafana is that it's more user-friendly. And Kibana is mainly whatever something happens in your system, you just search on it and you find out whatever you need. We do collect all the things around resources, JVM, application, and the business metrics, and create alerts. Create alerts like, let's say, the number of nodes that you have, and if something goes down, we do have alert. We do want to see whatever throughput higher comes in, or the latency is really high, and we didn't want to expect that. The latency, delay, data inconsistency itself, and things like that. So while having all of the pieces and you wanted to collect the data from different parts, we do implemented a lot of tools and mini applications that basically allows us to do that. So we want right now to group them in one single place so that we can control that only from there, right? And that's about the replaying, monitoring, and creating alerts, as I already said. We want to do more automation next. Right now, we do rely a lot on the on scripts created on for Amazon instances. Wherever a new throughput comes in, it will automatically scale up a new instance. We do not play yet with the downscaling, and there is a reason for that because of the partitioning of your data. You do get some of the challenges over there, but we will definitely want to automate that in the future, and. There are some of cost optimization in Druid. Druid itself is not only as a data source, it's more like a cluster of things. And you can optimize a couple of things over there. You might have some of your clients, let's say that for a certain interval, let's say Saturday and Sunday, that don't really use your infrastructure as they should be. So the throughput, it's really low on their side. So what you want is like, you want to say, okay, for those guys, I want to store their data on a lower instances. So you're kind of reducing your cost. You don't use all of your instances of the same type. You just create some of cheaper instances, and you put all of that data for that certain interval over there. So we succeeded to climb this mountain. Thank you very much.
Questions? We still have some time, so...
Yep.
Any questions? I can give you the mic. I'll pass it to you, so...
No?
It seems that you were very clear.
Whatever you have questions, guys, I will still be around, so please ask.
Erik, Artie, thank you so much once again. AdsWizz,
Thank you, guys.
I hope to see you next year, maybe, right?